Hello students, and welcome to the pre-lab video for forces in static equilibrium. So we've been studying Newton's laws of motion, and we know now they predict that a body in static equilibrium or experiencing no acceleration will have the effect that all external forces acting on that body will sum to zero. And we've learned that force is a vector quantity. So I want to introduce you to a device that we can use in the lab to verify this fact, the fact that the summation of forces acting on an object at static equilibrium do in fact equal zero. And this device is something we call a force table, and you'll see it's kind of like a circular table with the top of it laid out in degrees from 0 to 360. There's a little middle peg here, which is very useful. And then, of course, it has a stand here on the bottom. And we can use this to bring to equilibrium 2, 3, and even more forces. So to simulate the forces, you use these little pulley devices like this that need to be attached correctly. And we can put these at any position around the rim of the force table. So there's a screw on the bottom that allows you to just tighten it up to the rim of the table like that. And then we can, with a string, drape a hanger across the pulley. And then the weight on the pulley we will assume is equal to the tension or the force on the other side in the string. And using these, we can balance any number of forces on the force table. And then we can find the angle relative to the 0 point and use our trigonometry in 2 dimensions to verify the summation of forces is in fact 0. We will only study 3 forces. So to assemble the mass in the hangers correctly, you'll have a little ring like this, and then in our case, since we're studying 3 forces, there'll be 3 strings emanating from the ring. And you want to put your ring over that center thing in the force table. And then in my case, I'll demonstrate the balance of 3 forces. So I'm going to hang the little hangers over the pulleys here. And just like so, very simple to set up. And then the system comes to balance when this ring is perfectly centered over the little post in the center. And it can be tedious sometimes to get it straight, but I think I know a pre-assembled mass that will do it for me today. So I will get an equilibrium position here. So you see I pretty well have the system balanced. The ring is pretty well, it's not touching the post. So I can determine the mass on each hanger now, convert that to a force with the acceleration due to gravity, and that gives me the magnitude of the 3 forces. And then I can look at the degree layout, the angle layout around the force table, and I can get the angles I want so that I can sum forces in both dimensions, as you've learned already to do in your homework, and should be able to verify that they sum to 0. So just a few more hints for using the table effectively. Notice it has 3 feet, and you can adjust the height of the feet. So you would want to, before you start, to make sure the table is level. So you might lay a torpedo level on the top and adjust the little feet to make sure it's perfectly level. Another common mistake students will make, if you notice the little adjustable pulleys, you can also adjust the inclination of the little pulley there relative to the table. It goes up and down like that. And you want it adjusted so that the string is parallel to the face of the table. So a common mistake is that students will have the string below or above parallel to the table. So you see this one is adjusted just about right, and we want all of them like that, and we'll get a very good result. So that's a brief introduction to the force table, a very neat thing we use in the lab to verify the summation of forces in a static situation. So I hope you look forward to using this in the lab, and we'll see you in the lab.